Unreal's newest update, Unreal Engine 5.3, just released, and it is a big deal. The main reason is nanite landscapes. When Unreal Engine 5 came out, it introduced a revolutionary new way to render geometry called nanite. To briefly sum up nanite, every object you see in computer graphics is made up of tiny flat planes of geometry called polygons. The more polygons you have in your environment, the longer it will take to render. This is why video games have made a system called level of detail, or LOD for short. The further away an object is from the camera, the less polygons it will use to render that object. This makes games run faster, but we are limited in the amount of geometric detail we can have. Nanite fixes this, because it uses dynamic level detail, which means you can have an object with millions of polygons without any LODs, because the geometry deforms, lowering the amount of polygons on an object. A good example of nanite in use is this city. If I come up to lit, nanite, triangles, we can see nanite in action. Every color is an individual polygon, and there are millions of them. The biggest issue with nanite is that when it released, it only worked on non-moving static objects. It was only really good for objects like rocks and cliffs. This changed with the Unreal Engine 5.1 update. It introduced nanite foliage, which gave us the ability to create forests with an unlimited amount of detail. Here's a world with over 100,000 trees without any LODs. But landscapes, which is the biggest part of any environment, was still missing nanite. Landscapes allow us to create large open worlds easily. Using the tool, we can sculpt, add height maps, and paint different materials quickly. This means landscapes were stuck using low resolution geometry, and it hurt our game's performance because Unreal has a hard time rendering non-nanite objects. In all the tech demos Epic Games released, to avoid these issues, they didn't use landscapes. Instead, they faked landscapes. This desert ground isn't actually a landscape. Instead, it is a bunch of nanite objects stacked on top of each other to make it look like a landscape. Finally, in 5.3, nanite officially supports landscapes. To activate nanite, select your landscape, and then within the details panel, enable nanite, and then build data. Now that it's enabled, we can watch the geometry dynamically deform. It is that easy to enable nanite on our landscapes. In the first version of UE5, we made this village on the channel. But at the time, the only objects using nanite were rocks and the buildings. Now in UE 5.3, the entire world is nanite. There isn't a single object that isn't using nanite. This means we can get an infinite amount of detail from our environments, and the performance is a lot better. Nanite landscapes can now also use tessellation to add more detail. In UE4, we had tessellation, which allowed us to create displacements from a height texture. When Unreal Engine 5 released, it was removed. But now it is back and it is using nanite. This means we can change objects from the material editor. We have a brand new input called displacement where the height texture goes. Tessellation can convert any simple mesh into an object with thousands of polygons just with a texture. Here's an environment with a landscape that isn't using displacement. The world feels kind of flat, and here's the same landscape with displacement. The ground has depth to it, and it looks a lot better. Everything you see on screen, except the plants, is the landscape. All the rocks, twigs, and roots are not objects. They are a height texture. And whenever I make a change to my landscape, the nanite displacement remains in effect. For the first time in gaming, we're not limited by how many polygons are on screen. We can have infinite geometry everywhere. The next major feature is better volumetric fog and smoke. Unreal's had volumetric fog for a while, which gives us the ability to have realistic light scattering in fog and smoke. To enable volumetric fog is easy. You just have to click volumetric fog within the height fog to turn it on. Now we get dynamic fog that interacts with the lighting. So I can move the sunlight around and you'll see those God rays change direction. It is the secret to make any of your environments stand out. Here are before and afters of an animation with and without volumetric fog. The world feels more realistic and it looks visually more interesting with fog. The only issue in Unreal was that it was problematic to create finely detailed fog. It could only be used to create large splashes, and it was hard to use volumetrics for complex shapes like explosions. Instead, explosions and smoke had to be faked with billboards. Billboards are just a flat surface with an animated texture. You can see that this is just one single plane. The smoke isn't actually 3D. Obviously, this doesn't look the best, because when I move the lighting in my environment, the smoke stays exactly the same. We don't see any changes because after all, this is just a flat 2D texture. In 5.3, sparse volume textures fix this. We can now import complicated volumetric simulations from programs like Jenga FX. Here is a sparse volume explosion imported from Jenga FX into Unreal. And if I pause the simulation, you can see it is not being faked by billboards. This smoke simulation is completely 3D. If I move the light around, it will dynamically change the way the smoke looks. The smoke is able to cast shadows onto itself. We can even use sparse volume textures to represent clouds. And what's amazing about these clouds compared to Unreal's default cloud system is that I can move them around and rotate them. So I get full control over where my clouds are in the sky. And if we zoom out, we can even see that these clouds are massive objects that I can move around and place them exactly where I want them to be. Volumes can even replace some particle effects. For example, this fire here is very similar to the explosion, where if I go into wireframe view mode, it is just a couple of 2D planes that simulate a fire animation. And then if I look down directly at it, this effect immediately breaks. And now here's that particle effect, but it's replaced with a sparse volume texture. And this fire is now completely in 3D. It's not a 2D plane that's facing the camera. So if we look at it from the top down, the effect doesn't break. This fire is real and it exists in our world. Another major feature is that we can now create animatable characters directly in Unreal Engine. In Unreal, we have been able to create rigs and animate characters. This animation you're looking at right now was animated entirely in Unreal. It wasn't created in another program like Blender or Maya. The biggest part missing in the character creation workflow was skeletal mesh editing, which is the process of creating bones in a character. UE 5.3 adds a skeletal mesh editor. This means we can create bones and weight paint directly in the editor. It is now possible in Unreal through modeling, weight painting bones, rigging, and animating using Sequencer to create an entire character just using Unreal. We also get a new cloth editor to create realistic simulations for clothes. Users can define exactly how a cloth simulation can interact with a character, and then artificial intelligence will bake that interaction into an animation. Reflections also got a major update. If you don't know, Unreal Engine 5 introduced a brand new lighting system called Lumen. Lumen gives us dynamic bounce lighting in real time. It is important to know that bounce lighting is also called global illumination. Global illumination is a process of light rays bouncing around, illuminating your entire world. Before Lumen, game developers faked global illumination through a process called light baking. Light baking is rendering bounce lighting before the game is played. This render is then stored in a texture called a light map, which is then overlaid on top of the world to make it look like the light is bouncing around in real time, when in reality, it's just a pre-rendered texture. But now the problem is that global illumination isn't real time. As soon as I make a change to our light map, it is no longer in sync. We have to rebake the entire environment all over again, which is time consuming. This is why Lumen is a big deal, because it is true real-time global illumination. We don't have to bake our lights, but the downside is that Lumen is very expensive to run. Not every computer can run it because it is computationally intensive. This is why Unreal games like Valorant still use baked lighting. It is a competitive game, so every frame matters. If we open up a Valorant map in Unreal, you will see it using baked lighting. If I move an object, the light doesn't update until I rebake the environment. Even though Lumen exists, a lot of games still have to use baked lighting because it is just more performant. You could get 120 frames with baked lighting. It's hard to get that many frames with Lumen. Hardware hasn't caught up yet. This environment is using baked lighting, and one of the biggest issues with baked lighting is that it doesn't have any reflections. You'll see that this entire environment is broken because the reflections aren't working. And we can fix this by manually adding in reflections by using a reflection capture within Visual Effects, Sphere Reflection Capture. This will capture a 360-degree texture of my environment and then project it onto any reflective surfaces. The workflow to get reflections everywhere is that now I have to create another reflection capture and move it to where there's a bunch of reflections. And then I have to create another one and then continue the process throughout the entire environment. And if we have a large environment, this process can be very tedious. Here's an environment that's using Lumen and reflections work immediately. We do not need reflection captures. But the issue is that we had to use Lumen Global Illumination, which hurts our performance. In 5.3, we now have the ability to use Lumen reflections with baked lighting. So we do not have to use Lumen Global Illumination to get Lumen reflections. To get this feature, go to the post-process volume and set global illumination to none. So we're using the baked lighting and not lumen, and then set reflections to lumen. Now we're using baked lighting for global illumination and only using lumen for reflections. We get the high performance of static lighting with the accuracy of lumen reflections. Plus we no longer have to set up reflection captures. Also, lumen reflection now supports multiple bounces. So let's say we have a mirror right here, and then across the hallway we have another mirror. Notice how we can't see the other mirrors in its reflection. That's because we don't have enough reflection bounces. So if we go back into the post-process volume under reflections, we have a brand new setting called max reflection bounces. If I set this to 2, now we can see the reflections. The modeling mode user interface got a facelift, and now it is a lot easier to use. All the tools are neatly organized into categories. And let's say there's a tool I use a lot, like displace, then I can right click and add to favorites, and now I can quickly access that tool within the favorites tab. Masked materials like foliage are now 20% faster, and there are more shadow options for Nanite to help optimize shadows. Unreal shadow system called virtual shadow maps are right now the main bottleneck to foliage. So this gives us more control over what types of shadows should trees cast. And finally, a big update for Mac users, Nanite is now supported on all Apple M2 devices. Finally, Apple users have access to both Lumen and Nanite. When UE5 first released, it didn't have either feature. This also means that Unreal Engine 5 with Lumen and Nanite will be able to run on the Apple Vision Pro. The programs you're developing now on Unreal could be used for the Apple Vision Pro in the future. The possibilities are endless for Unreal. These were all the major changes to UE 5.2, but these are just the ones I think are important. Of course, there's a bunch of other changes you can check out by going to the Unreal release notes. Unreal is more important than ever because half of all next-gen games are being made in UE 5. There is no better time to learn Unreal Engine than now. Luckily for you, I have an entire free course right here on YouTube, which goes over the essentials to learn UE 5. You can learn how to create this world you see right now. You can check it out, link in the description below.